Hello, community. So great that you are back. Today we do deep research with Gemini 2.0 thinking model, the brand new thinking model for Gemini Deep Research. This is the free version. You can go there in the Gemini app and you can do this yourself. I have prepared a specific query, and you know me, this query has some specialities. So I just start here. I want to understand the differences between supervised fine-tuning and reinforcement learning in terms of their effectiveness for generating detailed reasoning for accurate responses to new unseen data. This is already something you should not do. This is a sentence too long, too complex, too interwoven with instruction. The AI might have problems, but hey, we are going here for the best system. So this is the benchmark. And then I'll go on, and I here put in a mistake. Because you know the GRPO, if we have this here, this is a group relative policy optimization, but I don't know this. I'm a student, so I write something that is simply nonsense. I write a gradient-based reward optimization. So let's see if the system is able, in the defined domain that I have specified here, to find out that I use here the wrong abbreviation or the wrong term here, the technical term, because here I say and policy optimization. So just to make sure, I go here and say, hey, PO stands for policy optimization, offers advantages to learn how to reason. Now I provide further details in chain of thoughts and beyond, like graph topologies, in complex structures, and integrate new knowledge. Again, don't do this. This is too complicated. This is too interwoven. But I do this because I want to test here the limits of the system. And I have here an instruction. I say, please focus on recent AI preprints and AI papers available on archive. Avoid content from commercial websites, Medium, LinkedIn, or X, formerly Twitter. So, and if I say go, and this is the free version, so please go yourself, Gemini 2.0 comes back and have put together a research plan. This is nice. So it just tells me, hey, I think I should do this. What do you think? If you need to update it in any way, let me know. So let's have a look. It says, I want to understand the different supervised fine-tuning, and yes, I'm interested whether techniques like, it did not recognize that this was a non-existent term. Okay, so failed here the first one. And then we have here the different steps, that now 8 steps, okay, that the system tells me, hey, I want to do this. So let's see. Let's look here and search and compare supervised fine-tuning, reinforced learning. Yeah, identify papers that specifically analyze the effectiveness in enabling to generate detailed reasoning for accurate responses. Yes. Find research papers on AI that investigate reinforcement learning, still the wrong term, and other policy optimization offer significant advantages. Yes. So it was able to decompose the complexity of my sentence into 3-4 simpler complexities. Look for papers how to discuss, how to perform reasoning, including chain of thought, and more complex reasoning structures. Yes, correct. You see, it breaks it down in simple steps. Search the paper to explore how reinforcement learning trains LLM to perform reasoning, including chains of thought and graph topologies. Identify reason that enable this. Find studies, evaluate the performance, complex and new information, and present it to new unseen data. So we have now the unseen data, and synthesize the findings to provide a comprehensive overview. There are some redundancies here in those 8 points, but I think that's okay. So let's just go. Let's say, okay, so I could edit the plan if I have some problems, but I would say no. Let's go, analyze then the results, create a report, and you are with me in real time. Let's have a look if the system is able to find anything. Start research. So you are alive. Okay, nice. Starting research. Interesting. Yep. Show thinking. Yes, show thinking would be nice. I like to see what the system is doing. Understanding the training methods. I'm starting my research by looking into fundamental differences between supervised fine-tuning and reinforcement learning. I plan to investigate how each of these training methods influence the model ability to generate detailed reasoning. Interested in understanding are still the wrong term. Okay. Investigate in reasoning structures, okay. Research websites, okay. Initial findings, okay. My initial search has surfaced several recent papers, okay. I also identified that papers that delve into how they are used, the chain of thought training, beautiful. Knowledge integration insights, a paper on self-training with process preference learning appears to touch upon enhancing this. Get more complete picture. I need to refine my search queries. Okay. Found new websites from new studies. Reasoning with limited data is a new study. Okay. Combining the training methods. Yes. Challenges in RL reasoning. There's a specific paper on thought collapse. Yes, beautiful. I have a video on this. Further explanation. Research websites. So found more studies on archive. This is really stick here. Perfect to my guidance. Comparison found. There was a paper on this. Role in reasoning. Beautiful. Reinforcement learning from human feedback. DPO. Yes. So we found already 2 of the terms we're looking for. Key paper. Next step. Focus on reading this new found paper and extract the key comparison. So new papers will read the paper, extract the paper. Outperforms in language understanding. New paper, provide new knowledge. Nice. I hope you counted how many papers we already read together. But it's nice. I mean, for 23 websites. Okay, so we have this information here. I mean, for free. This is absolutely free. This is real nice from the structured present itself. So let's see. Tell me, feel free to leave this chat. I'll let you know as soon as I'm done. This is nice, so there's no further interaction here with a human. Just thinking. Are we still thinking? Yes, we are still thinking. Show thinking, yeah. What else we have? Sites. No, I want to stick with this thinking mode for a minute. Further investigate how reinforcement learning can be used for more complex reasoning structures. Beyond simple chain of thoughts, I will now examine 2 newly identified papers that appear to focus on this topic. Nice. Yeah, absolutely. So I would say almost like a human student. No, you go step by step through all the possible things. You have your plan. You have your meta thinking. You think about how to think about something. Great. And okay, these new papers seem to be quite complex because we're waiting here for Gemini 2.0 thinking with the new thinking model available now for 1 day. I hope there are not too many people right now trying to do the same thing here. Okay. Edge in reasoning. I've observed that reinforcement learning, particular PPO, tends to outperform supervised fine-tuning in language understanding, yeah. For reasoning foundation, plays a crucial role in establishing the groundwork for reasoning, supervised fine-tuning, okay. Also, I counted issues accessing a couple of papers that might have provided insight into how reinforcement learning is used for complex reasoning structure. I will now focus on synthesizes the information I've gathered so far. To address the initial question, no, I see. This is now the answer. Okay, this was the thinking done. And now somehow we have now generated here an answer. So let's have a look at the answer. Supervised fine-tuning versus reinforcement learning for detailed reasoning in LLMs and comparative analysis. Let's see. Remarkable advancements. Yes. Yeah, while both approaches have demonstrated significant success, increasing demand for models that can exhibit robust reasoning abilities, particularly when faced with novel unseen data, necessitates a deeper understanding of their respective strength and limitation. True intelligence in these models required a capacity to navigate intricate problems and extend learned patterns to unfamiliar scenarios. It understood my question perfectly, moving beyond rote memorization to a genuine comprehension of fundamental principles and relationships. Address this topic. Okay. Supervised fine-tuning for reasoning in LLMs. Development is the concept of chain of thought prompting. Yeah, involves training LLMs through datasets where each example includes not only the question and the final answer, but also a sequence of intermediate reasoning steps that lead to the solution. So it understood what is chain of thought. The ability to produce this reasoning step was primarily elicited through careful crafted prompts that provided a few examples of chain of thought. Researchers found that fine-tuning models on dataset explicitly containing these reasoning sequences could make this capability more consistent and reliable, effectively embedding the ability to reason within the model parameters without a constant need for extensive in-context learning example. Correct. Beautiful. This shift from relying on prompting to incorporate fine-tuning signifies an effort to make reasoning a more intrinsic attribute of the model. Learn more. There I have here my link to this particular paper. However, while annotation has proven effective for certain types of reasoning, it faces limitation when dealing with highly complex problems or those requiring non-linear reasoning structures. Yes, studies indicate that training models here on provided chain of thought order alone might not lead to sufficiently strong generalization. Correct. In mathematical problem solving, training data often contain only one annotated reasoning path for each question. This can lead the model to learn to mimic the specific path without developing a deeper understanding of the underlying mathematical principles. Yes. When confronted with a novel problem that necessitates a slightly different approach, the model might struggle because it has not been trained to explore alternative reasoning strategies. Absolutely correct. The reliance on static predefined reasoning paths in the training data can hinder the model's ability to adapt to new scenarios and discover potentially more efficient problem-solving methods. Correct. The core issue appears to be that SFT primarily teaches the model to reproduce patterns observed in the training data. Yes. If the training data only demonstrate one way to arrive at a solution, the model's capacity to explore the broader space of possible reasoning steps remains constrained. This is correct, and this is the study. I don't want to click on this because I want to go on with the reading. Furthermore, the effectiveness of supervised fine-tuning and enabling LLMs to integrate and utilize new knowledge encounters after the initial training phase is limited. SFT typically involves training on a fixed data set. To incorporate new information, it requires further fine-tuning on data that include this new knowledge. Okay? Can be computationally expensive and might also lead to a phenomenon known as catastrophic forgetting. Yes. Where the model loses previously acquired knowledge while learning new information. Correct. Research and code generation suggest that as supervised fine-tuning progresses, models might tend to memorize the original prompt and its solution together, leading to difficulties in generalizes to even slightly modified problems. Beautiful. Yes, this is it. Tendency highlights a potential challenge for SFT in truly understanding and integrating new information in a way that allows for a flexible reasoning. While in-context learning might allow models to utilize some new information provided in the prompt, this is not a robust and scalable solution for truly incorporating and reasoning with novel facts or concepts in a consistent manner. And another archive paper, scientific paper. Great. Now to reinforcement learning. Reinforcement learning from human feedback and reinforcement learning from AI feedback offers an alternative approach to training LLMs that aims to address some of the limitations of supervised fine-tuning in fostering detailed reasoning. Instead of relying on explicit annotation of the reasoning process, RL trains model based on reward signals that incentivize desired behavior, such as generating accurate and detailed reasoning. Correct. While the provided material does not explicitly mention my wrong technical term, gradient-based reward. Yep. So it was not looking for, this is interesting, look, does not mention, now I have here the complete technical term and not the abbreviated technical term, because there is the abbreviated technical term, but given here the term, it was just searching here for this string and I did not understand that the string is wrong, but the abbreviation is right. Okay. The general principle of reinforcement learning involves optimizing the model's policy, to maximize the expected cumulative reward. Correct. Often involves using policy gradient methods to adjust the model's parameter based on the rewards received for its actions. See my last video, we went through the mathematical formulas. Also shows promise in facilitating the learning of reasoning that extends beyond simple linear chains, yes. Enabling the exploration of more complex structures like tree and graphs, yes. For example, one studies in guided thought reinforcement, GTR. I have a video on GTR just days ago, yes, to address a phenomenon called thought collapse in reinforcement learning-based vision language model. I called it robotics. I leave the link to my video here, Vision language model agent training, where the agent rapidly loses diversity in its reasoning, emphasizes the necessity of providing access process guidance, a process reward system during reinforcement learning to ensure the model develops sound reasoning. Another paper focuses on using RL to train language model to reason effectively by dynamically allocating computational resources, inference time-based, TTS, test time compute scaling, based on the complexity of the task, by rewarding models for achieving accuracy with minimal computational overhead, can encourage more reasoning patterns. Reason flux. Yes, I have a video on reason flux. Hey, wow! This is really nice because it really takes the latest paper of this week. Presents here a hierarchical reasoning approach that utilizes reinforcement learning with a library of thought templates to significantly enhance mathematical reasoning capabilities. Correct? This suggests that structuring the reasoning process within an RL framework can be highly effective for tracking complex problems. A comprehensive blueprint for reasoning language model highlights how RL is a core component in architectures designed to support diverse reasoning structures, including chains, trees, and graph. Training collectively suggests that RL provides a framework to guide models toward better reasoning by rewarding successful outcomes and reasoning processes. Yes. Approach has the potential to enable the discovery of more effective and complex reasoning strategies compared to those explicitly provided in supervised fine-tuning dataset. Techniques like GTR and hierarchical RL represent advancement. Correct. While no specific snippet directly addresses the use of reinforcement learning for integrating new knowledge, the dynamic nature of RL, where the model interacts with the environment, suggests potential advantages over the static nature of supervised fine-tuning. Okay. In an RL setting, the model could be exposed to new information during the learning process and receives a reward based on its ability to use this information to improve its reasoning and problem solving. This interactive learning paradigm could be more conducive to continuous learning and knowledge integration compared to the discrete training phases typically associated with supervised fine-tuning. The ability of reinforcement learning agent to learn through interaction and adapt new information in the environment could potentially be leveraged to enable LLMs to incorporate new knowledge more effectively than supervised fine-tuning. Chapter 4, Exploring Reasoning Beyond Linear Chains. Hey, now we come. Look here, the reason flux frameworks, which employs hierarchical reinforcement learning on sort templates, also demonstrate a move towards more structured and potentially nonlinear reasoning processes. This development indicates a trend beyond traditional linear chains of thought toward more sophisticated reasoning structures, with reinforcement learning playing a significant role in the development. This is correct. Nice. Research on graph of thought and other sophisticated structure aim to equip LLMs with the ability to perform this kind of intricate information integration. The use of reinforcement learning appears to be a key enabler in this transition. Yes. Nice. We have here a new paper, multiple paper, the reasoning flux paper. Okay, a blueprint, reasoning language models. Hey, more. Nice. Okay, let's go on. Well, the provided snippets do not explicitly detail supervised fine-tuning approaches for training LLMs to perform reasoning in nonlinear structures. It is plausible. Now Gemini says it is plausible. Okay, careful. That researchers are exploring methods to structure supervised fine-tuning data to represent these complex reasoning paths, creating data sets with annotated reasoning graphs or tree, where the training example demonstrate how different pieces of information are connected and processed on a non-sequential manner. Correct? The challenges lies in creating such comprehensive and diverse data sets that can effectively capture the vast space of possible complex reasoning patterns. Correct? The ability of RL to learn through trial and error and optimize for desired outcomes in dynamic environments might offer a more flexible and scalable approach for acquiring those more complex reasoning capabilities. Beautiful. Chapter 5. Integrating new knowledge. Supervised fine-tuning. Computational expensive, suggested by the research in code generation, supervised fine-tuning might lead to memorization rather than true generalization, potentially hindering the effective integration of new, slightly different information. SFT might face challenges in seamless knowledge integration without explicit retraining on data containing the new information. Correct. I have even my paper. Beautiful. In contrast, reinforcement learning with its interactive nature, holds potential advantages for enabling LLMs to dynamically integrate and reason with new information. Yes. In a reinforcement learning framework, the model could be designed to interact with the environment where new information is introduced. The reward function could then be crafted to incentivize the model to utilize this new information to improve its reasoning and achieve better outcomes. Correct. This dynamic learning process offers a more natural way to handle evolving knowledge compared to the batch-based training of supervised fine-tuning. While no specific snippet directly confirms this, the inherent ability of reinforcement learning agents to learn from their experiences and adapt their policies based on the new inputs suggests the potential superiority over supervised fine-tuning in scenarios requiring continuous knowledge integration. Yes, I would go with this. Chapter 6. Wow, this is really interesting. It got the main points. Supervised fine-tuning offers the advantage of relative simplicity and effectiveness with high-quality annotated data, such as chain of thought example. It calls for direct learning from demonstration of the desired reasoning process. SFT reliance on the training data can also be a significant limitation, potentially restricting its ability to generalize to novel problems or explore alternative reasoning paths. New knowledge often requires substantial retraining. In the best way, a pre-training. Reinforcement learning, on the other hand, provides a framework for training LLMs based on rewards, which can incentivize more complex and nuanced reasoning behaviors. Yes. Studies suggest that RL can be particularly effective for smaller models. Yes. And in data sparse scenario for enhancing reasoning. Correct. Appears to have higher potential for achieving advanced reasoning, especially for long chain of thought processes and for further improved models initially trained with supervised fine-tuning. Yes, at first you go with the SFT and then you apply your reinforcement learning. That's a good idea. Check it out if it's valid for your specific system. However, RL-based fine-tuning such as proximal policy optimization, or PPO, has shown significant improvements in natural language understanding. Granular feedback in RL has even led to the emergence of sophisticated reasoning behaviors. RL is not without its challenges. Yes, it might be more complex to implement and require significant effort in designing effective reward function and tuning the hyperparameters. Yes. Training can also be unstable, potentially leading to undesired outcomes. Yes. The emergence of a more efficient preference-based learning methods like DPO, direct preference optimization, indicates an ongoing effort to address some of these computational and stability issues associated with the traditional reinforcement learning approaches. 1, 2, 3, 4, 5, 5 papers. Nice. The suitability of supervised fine-tuning versus reinforcement learning depends on specific reasoning tasks. Yes. SFT may be sufficient for tasks where the reasoning process is well defined and can be effectively captured in the training data. However, for more complex tasks requiring exploration, RL appears to offer a more promising avenue. Absolutely agree with this statement. So then we have a table, comparison of SFT and reinforcement learning for reasoning in LLMs. And then we have our conclusion. So let's go through this. I think it will be correct because up until now, everything was just perfect. Training data, annotated examples, question-answer pair, chain of thought paths, interaction with the environment, reward signal based on the outcomes or reasoning quality. Yeah. If we go with the outcome-only model, we have now the process reward models, but learning mechanism and mimicking provided examples. This means we learn patterns. And we, kind of copy patterns that we encountered here in the supervised fine-tuning training data set. RL, optimize a policy to maximize cumulative reward. Correct. Effectiveness, effective with sufficient high-quality chain of thought data. Effective, especially with well-designed reward function that's sometimes real complex to decide, especially if you go with PPO and you have the value function. Complex reasoning, limited by the diversity and structure of the training data. It all depends on the quality of your training data. And RL, promise with mutex leak, the hierarchical RL and graph-based reasoning. Correct. Generalization can struggle with novel problems beyond the training data. Yes. If you have reinforcement learning in robotics, potential for better generalization through exploring and reward-based, let's say, self-learning, because the robot interacts with its environment. So absolutely, the agent interacts with the environment. New knowledge integration requires retraining. Yes, absolutely. or fine-tuning on data with new knowledge, potential for dynamic integration through interaction, adaptation of policy, correct training stability, more stable, can be unstable, requires careful hyperparameter tuning, this is correct. Computational cost, typically lower, this is a very general statement, I don't know if this is true, can be higher, yes, absolutely, okay. Data efficiency, small models, may struggle in data sparse scenario, yes, can be more effective, correct. Long chain of thought, potentially lower than reinforcement learning, the upper limit. Higher upper limit can further improve models initialized with long chain of thought supervised fine-tuning. Absolutely, this is also my experience. If you go here and the first step with some supervised fine-tuning for your training examples that include a long chain of thought reasoning sequence, and then you start with the reinforcement learning, this can really be the right way. Step 1, supervised fine-tuning. Step 2, reinforcement learning on top of it. Improves over zero few shot, but may be surpassed by RL. Yes. Emergent behaviors, less likely to exhibit novel reasoning strategy in our supervised fine-tuning. Correct. Can lead to emergent reasoning behaviors. Theoretically, under the best circumstances, if we go here for an ideal system where we have no noise in the system, where we have beautiful sensor signals coming back and everything else, less demanding hyperparameter tuning often requires extensive hyperparameter tuning. Yeah, alternative approaches, prompt engineering, DPO, correct. Everything is correct. Unbelievable. Conclusion and future direction. The current understanding based on recent research suggests that both supervised fine-tuning and reinforcement learning play crucial roles in enhancing the reasoning capabilities of LLMs. Supervised fine-tuning provides a solid foundation, particularly when high-quality annotated data demonstrating the desired reasoning processes is and are available. Yes. However, its limitation in generalizing to novel scenarios, handling complex reasoning structures, and seamlessly integrating new knowledge highlight the need for complementary or alternative approaches. Reinforcement learning emerges as a powerful technique for overcoming some of these limitations. Its ability to train models based on reward signals allows for the exploration of a broader range of reasoning strategies and hold promise for enabling more sophisticated reasoning, including structures beyond linear chains. Perfect. RL offers a potential pathway for more dynamic integration of new knowledge. Yes. Practical challenges associated with reinforcement learning, such as the complexity of the reward design and the training instabilities, necessitate further research and development. Beautiful. This is why we have this research channel. Emerging trends indicate an increased interest in leveraging RL for complex reasoning tasks and the development of more efficient and stable RL alternatives like DPO. Open question will remain regarding the optimal design of the reward function for guiding intricate reasoning processes, the scalability of RL for extreme large models, and the creation of robust models for continuous learning and knowledge integration. Continuous learning will be a topic of next week, maybe. Further research could explore hybrid approaches that strategically combine the strength of supervised fine-tuning and reinforcement learning. Supervised fine-tuning could be used to initialize the model with basic reasoning skills, yes, followed by RL to further refine and enhance its abilities, particularly for complex tasks, yes. Investigating novel reward mechanisms can effectively guide the development of sophisticated reasoning strategy. This is also crucial. The development of benchmarks, specially designed to evaluate reasoning with new knowledge and in complex structure, will be essential for driving the progress in this field, and the potential role of self-supervision in further enhancing the reasoning capabilities, perhaps in conjunction with supervised fine-tuning or RL, also warrant significant attention in future investigation. Absolutely fine. Sources used in the report, 1, 2, 3, 4, whatever. Sources read, but not used in the report. 2, sorts. Here we have the thinking process again. So I have to tell you, for, 2 or 3 minutes for deep research that it took on this particular topic, it referenced here only research.archive.org AI papers, as I specified here. So I have to tell you, absolutely amazing. Yes, expert to docs as a new document. Okay, you can go here with whatever, you can copy it and you can close it. Nice. I like this answer. If you're new to the topic, I have to tell you, after looking here in detail to each and every single sentence, I could not find a single mistake. This is really nice. It makes sense. Is everything included? What I would have told you? No. Is it presented here in a perfect, I don't know, pedagogic way? Maybe not so, but information is correct, gives you a good overview. I am impressed with the performance of Gemini 2.0 thinking for the deep research exercise. Great. So let's have a look. We go now to OpenAI, to ChatGPT o3 Mini High. We have a deep research. Hey, I got 8 still available on this topic. And you know what? I paste here the exact same topic like we just did with Gemini. You again have here that I used here on purpose here the wrong term, the wrong technical term for this correct abbreviation, GRPO. And now let's see exactly if we activate deep research. Okay, what are you researching for? This one. You are live with me. Let's see what it's doing, what's happening. I will research recent AI preprints. Beautiful. To refine my search, could you clarify? Are you interested in specific domains, scientific reasoning, programming, or general purpose reasoning? Should I focus on particular model size range? Do I prefer comparison? Or both? Are you interested in recent papers only, or slightly older but influential work? I'll tailor the research accordingly. So I define my answer. I say, hey, focus on scientific reasoning and mathematical proofs. Look at a complete spectrum of all the model sizes. I prefer theoretical analysis with performance data and focus on the latest AI papers and preprints. And here we go. So let's see. Got it. I will research recent papers. Beautiful, including gradient-based. Still did not understood that this is the wrong term. I will prioritize theoretical analysis, empirical performance, range model, chain of thought, graph-based reasoning, structured knowledge integration, starting research. I will get back to you once I have gathered relevant insights. Starting research. Hello? Here we go. Activity. Yeah, thinking. Nice. You have to click on this. Okay. I'm evaluating. This is nice, huh? I'm looking at GRPO. Might indicate group relative policy optimization rather than gradient-based reward optimization. Correct. Nice. So it understood here that this abbreviation has not the correct terms. I might not know this as a student. Okay. I'm digging into RL approaches like GRPO for chain of thought reasoning. DeepSeek Math Instruct 7b, gathering information RL policy optimization, DeepSeek R1 and CPO references, thinking about the use of O1 series models by OpenAI. Hey, what a coincidence that OpenAI thinks about its own models and its own products and its own offerings. I'm working through GRPO method, which skews a critic model using group sampling. Yeah, correct. I'm working on a structured comparison. Beautiful. Examining reinforcement learning from Evolve Instruct feedback. Okay, OpenReviewNet, interesting. Up until now it was archive.org. I'm mapping out GRPO as simplified policy gradient. Yes. Group scores as a baseline to cut down variance. Yes. It is simpler than PPO. I'm digging into a paper that seems to explore giving something for the reasoning process. Check the ARIMA model's persistent plot and found that white noise component stationary due to the... Okay, no idea what ARIMA stands for. Mapping out the relevance of 2 documents of fine-tuning effects on chain of thought reasoning. Hints at reinforcement learning methods like CPO. I'm curious about combining search methods like tree of thought with supervised fine-tuning for preference alignment. Checking the table in the PDF to understand the data in OpenReviewNet. Why you go with OpenReviewNet? I noticed the archive link is not functioning. Searching for improving chain of thought reasoning in LLMs. Seems to match. Beautiful. Let me see. The abstracts highlight supervised fine-tuning challenges on our methods, CPO, GRPO, and Oreo. Thinking through the impact. Okay. So it's reading the abstracts. Hopefully it's not reading the abstracts only. Okay, consulting the latest advancement in wizard math, pulling up PDF to grab performance metrics, looking at how wizard math excels over other open and commercial models in various benchmarks. Gaps with GPT-4 still exist. GPT-4 is my grandfather. Fine-tuning LLMs using knowledge graph to boost reasoning. 19 sources, okay. Checking how distilling DeepSeek R1 to smaller models outperforms, okay. Direct distillation from larger models shows promising progress. Yeah, that's true. Still reading. Interesting. Still reading 19 sources. Not really what I would have supposed that it would find or that it would go for. But okay, I don't know about its search process here on the internet. What papers it finds, it does not find at all. So the DeepSeek paper R1 is a good information source, absolutely. Plus GRPO is directly in the DeepSeek MAT paper, you know, it's not in the R1 paper. So let's see if it finds the MAT paper by DeepSeek. We are still waiting. We are still waiting. Not gonna believe it, we are still reading. You can skip it. I have to stay here online in real time because I want to understand about the activity, the thinking process itself. If it's better than Gemini. Let's see, this is also the free, no, this is here the plus version that I use. Okay, sorry. So for if you have the plus, you know, this $20 per month account, this is the plus. You have here this, and I think deep research is also free. Let me check at the end of this. I'm mapping out GRPO's potential for RL tasks. Optimizes a broad learning goal by integrating new data to bolster language model capabilities. What? The whole minute you was just looking here at GRPO's potential? Come on, this is a human would need that much time. It's still thinking. Okay. Okay. So if you have the $20 account per month, this is what you will get. I'm thinking through how RL can refine existing knowledge, considering the benefits of distilling knowledge from larger reinforcement learning trained models compared to direct RL and smaller models. This is a good idea. This is nice. Okay. Excels in offline learning. Okay. AlphaWorld. Yes. Okay. I'm working through how Oreo multi-step reasoning outperforms offline methods, considering fine-tuning impacts on maintaining diverse chain of thought reasoning. Yes. Okay. So we again see, hey, how important it is to have a supervised fine-tuning at the beginning and then continue here with reinforced learning, or is supervised fine-tuning not at all a necessity that we have to do before reinforcement learning? Fine-tuning tasks could decrease chain of thought faithfulness, undermining logical consistency. So fine-tuning task, no. 2023 research on process level feedback. This is, hey, more than 2 years old. Come back to the reality. Process supervision outperforms outcome, supervision and training models. I'm not happy that it is looking at 2023 research. Okay, this is not archive. New knowledge tricky. They mix existing insights and chew on fresh data, which can cause hallucination. What does it mean? They chew on fresh data. A language model doesn't chew on fresh data, which can cause hallucination. This is nonsense. You see, no idea what about this, but no. Focusing instead on predictive nuances. What is the meaning of predictive nuances in detail? Details are missing here. Reading. I'm not that impressed. I mean, 25 sources, okay. But what I've seen till now, including your 2023, AlphaWorld, I don't know, there are some major studies missing here in this. Why is it not here examining here the latest studies in the field? Okay. So either, yeah, it says here, 2024 onwards. So either it doesn't find anything, or maybe here the web search is not really that advanced like Google, which would be understandable. Google has many years and decades ahead for scroll here through the web. It is reading. What are you reading, my little one, huh? Tell me. 25 sources. We are about, I don't know, 70% through. Read archive.org. Yeah, archive.org, this is nice. Graph PRM, a process reward model, uses Monte Carlo tree search to generate step-level data. Now it's on the right track. DPO is employed for fine-tuning with this preference, avoiding complex reinforcement learning training, especially the value function. Okay. I explore the latest enhancement in credit assignments. Okay. Reward assignments, ORL. Yep. Ability to generate chain of thought and integrate external knowledge is particularly promising. Okay. Read archive. At least it's now reading archive. 27 sources. We are at 75% or so. That's thinking. From the feeling, I would say it's taking a little bit longer than Google's. But who knows? You have a better chance because you can scroll forward and backward in the video and you can compare here the recording times. I'm here live, so I just can tell you what I am feeling right now. And I'm waiting for OpenAI to finish reading this particular paper. Suppose archive.org. I just don't want to click right now on archive.org because I want to see the complete reasoning process here to tell you if this is a better deep research model. On our particular task, we are still waiting here. Come on, my little one. You can do this. I believe in you. 27 sources, close to 80%. Oh my goodness. Still waiting. Completed. Wow. Referencing removal. Research completed in 8 minutes. 27 sources. Beautiful. This is it. So the sort process is done. We have now here on the left side, we have now the paper itself. Okay. Research completed in 8 minutes. Supervised fine-tuning versus reinforcement learning for scientific. Yes. Now, I will just fly over this. I will not read it out loud, but it seems to be a rather detailed study. But I'm just interested, does it get the latest study? Does it get the latest research ideas? This is all I'm interested in. I'm sure you can have this on your screen or record this in 4K, so no problem for you. Gradient-based reward optimization. So although it understood that this was here the wrong term for this abbreviation, it still goes here with my input, which is a wrong input. I thought it would have understood that these two terms do not go together, but whatever. Structured reasoning, supervised fine-tuning, RL. Okay, fine-tuning and detailed chain of thought, annotation of formal proofs. Multi-step solution. SFT is effective at injecting domain knowledge and structured patterns into the model behavior, but it is constrained by provided data, by the quality of the training data, yeah. The model cannot easily exceed the creativity or coverage of its training example and reasoning. Correct, yeah, but would never have assumed that this is possible. There's also a risk of overfitting to specific solution styles. Yes, a catastrophic forgetting of general capabilities when fine-tuned on narrow tasks. Correct. Yeah, beautiful. Here we see the studies. Nice. Recent study found that task-specific fine-tuning can even reduce the faithfulness of the model's own chain of thought reasoning on the task, suggesting shifts in the internal reasoning mechanism. Okay. Supervised fine-tuning imports reasoning heuristics through mimicry. Yeah, it shines when abundant correct solutions are available, but may struggle to generalize beyond its training distribution. Correct. Reinforcement learning, by contrast, optimizes the model behavior toward a reward function. In an RL setup, the LLM generates reasoning steps and completes solution and receives feedback, either at the end of the solution, an outcome-based reward, or at each step, a process-based reward. Correct. RL directly targets the outcome quality, whether the proof is correct or the answer is right, rather than just mimicking a reference solution. Yes? In theory, this allows the model to explore and discover reasoning strategies that yield higher reward, potentially surpassing the limitation of its initial training data. If you have a high feedback from your environment that you are interacting with, yes. It also enables learning from implicit signals, using correctness checks and preferences as feedback instead of requiring full step-by-step supervision from humans. Yeah. Key theoretical advantage is in credit assignments for multi-step reasoning. RL algorithms can assign credit. Yeah. Recent work stresses that fine-grained credit assignment is especially critical for the correctness of reasoning trajectories, often depends on a few key tokens. Okay. By training a value function or using step-by-step rewards, RL can reinforce those pivotal steps. Process supervision, giving feedback at each reasoning step, has been shown to significantly outperform only outcome-level feedback. Yes. Yielding more reliable problem solving. Yeah. I know this study. Correct. In theory, all trained model can learn a more deliberate and optimized reasoning policy rather than simply echoing training examples. That said, RL is not a free lunch. Designing an appropriate reward signal is challenging. An overly simplistic reward can lead to reward hacking, where the model finds loopholes, yes, writing answers that trick a scoring model but are not truly correct, yeah. Ensuring training stability is another concern, absolutely. RL updates can destabilize language coherence if not carefully constrained. PPO introduce a callback library divergence penalty to keep the update policy close to the pre-trained model's behavior, balancing exploration with stability. Okay. Recent innovation, gradient-based rewards optimization. This is wrong. GRPO is not gradient-based reward optimization. GRPO is group relative policy optimization. Xiao et al. Modifies PPO to further improve stability. This is true for the abbreviation, but this is the wrong technical term. Here, we introduce group relative policy optimization. So this is interesting. So it took still my input. This was here. This is the wrong input. And my input was stronger than the result because here it retrieved group relative. This is not okay because I can make a typo or I mix up reward and policy. This is not okay. GRPO removes the need for a separate value critique network. This is correct now for the group relative policy optimization, which for LLMs would be as large as the model itself and estimate the baseline reward by sampling a group of model outputs and taking the advantage as a reference. This is correct. Yep. The group advantage approach greatly reduces memory CPU overhead while stabilizing training. Yes. Effectively making RL feasible even for larger models. Correct. In summary, reinforcement learning offers a principled way to directly optimize reasoning quality, encourage the model to use knowledge effectively, but it requires careful algorithmic design. Yes. Empirical performance, 2024 to 2025, confirmed this theoretical expectation. Combining reinforced learning with LLM training has led to state-of-the-art reasoning performance in several scientific domains, often surpassing what pure supervised fine-tuning can achieve. Yes, absolutely. A DeepSeek Match project. Yes, this is it. GRPO. Yep. Significant jump without adding new supervised data. Yeah. Please read the Math instruct models here in the paper 14. Okay. Wizard Math Microsoft. This is where Wizard Math is coming from Microsoft. Okay, let's jump over this chain of thought reasoning. Fine-tuning on chain of thought data enables models to produce step-by-step solutions, but RL can further improve the correctness. OpenAI's recent O1 series model repeatedly use inference time chain of thought scaling. So this is test time compute scaling. sampling multiple reasoning chain to boost accuracy. DeepSeek R1, okay. However, research from DeepMind, OpenAI found that explicitly training on stepwise reward yields even better results. Process supervised RL step-by-step feedback led them all to solving 78% of the problems from a test set, significantly more than outcome supervised training could achieve. Yes. Process reward models evaluate each intermediate step. Yes, and have demonstrated exceptional performance in complex reasoning by offering fine-grained supervision. Correct. Okay. Littman 2023. No. 2024. Chain of preference optimization. No, this is old. Graph-based reasoning and structured knowledge. Hey, nice! Reasoning on graph-structured problems like pathfinding or network analysis in a knowledge graph is another frontier. Yes. Recent work has applied RL-style supervision here as well. The graph process reward model to score each step at a graph reasoning model. Because graph problems have well-defined algorithms, they could automatically generate step-level incorrect labels and train a process reward model without manual effort. Yes. Okay. Then they used the PO approach to fine-tune the LLM. The PRM's evaluation created preference pairs, good step versus bad step, which the model was optimized to satisfy. This yields a model that solves graph tasks more reliably and interestingly also generalized those gains to other reasoning domains beyond graphs. To a very limited perspective, this might be true. The rewarding graph reasoning process makes LLM okay. Study concluded that the reward-based training on graph problems can boost the LLM graph problem solving and improve performance in other complex reasoning tasks. Yes. In terms of integrating new structured knowledge, fine-tuning is still the primary tool. Wow. 2024 title integrates too old. A controlled study found that simply fine-tuning a new factual statement is slow and can increase hallucination tendencies. This is this one. Okay. Large models mostly acquire knowledge during pre-training. Yes, this is it. Post hoc fine-tuning on relatively new facts is inefficient. Absolutely correct. And may teach the model to generate ungrounded answers if not done carefully. Absolutely. In practice, if new knowledge integration is the goal, supervised fine-tuning on structured knowledge might be safer, whereas reinforcement learning could be used to penalize hallucination or encourage citing sources. Okay? But direct RL to insert new knowledge is uncommon. It's usually about improving reasoning with the knowledge the model has. Yes, of course. The task has required combining multiple pieces of information, multi-hop science question. Human feedback style training can encourage the model to perform that multi-step because the reward will be higher for coherent, correct reasoning that uses all the facts. Beautiful. General scientific reasoning. Beyond math and graph. The combination of supervised fine-tuning and reinforcement learning has been applied to scientific question and answer, logical reasoning, puzzles, and coding. OpenAI internal experiment, come on, indicate that pure RL approaches were starting to catch up to heavily supervised ones on general reasoning benchmarks. DeepSeek R1. Okay, this is the study that it found most interesting. None have yet matched the very largest proprietary models on all tasks, okay? DeepSeek R1 0, yes, we know this. Our only models still lagged a bit behind in models that had an initial supervised fine-tuning phase. Yeah, but the gap is closing. This is now an interesting piece of information. Absolutely correct. DeepSeek R1. Yeah, DeepSeek R1. Okay, great. Another empirical trend is using offline reinforcement learning algorithm which train on a fixed data set of model trajectories with reward instead of online sampling. ARIA algorithm is such example. Yes. Direct preference optimization on the different benchmark achieved 5% accuracy. Beautiful. Impact on chain of thought, knowledge integration, and reasoning style. Both supervised fine-tuning and reinforcement learning can produce models that explicitly reason through chain of thought, but their effect on the quality of those chains differ. Chain of thought quality. Supervised fine-tuning will train the model to produce a reasoning chain that looks correct because it mimics human-written solutions or training data solutions. However, those chains are not guaranteed to be actually useful or minimal. The model might include some steps or make leaps it cannot justify as long as it looks like the training example. Yeah. Unfortunately, there is no real reasoning here in our AI. Our supervised fine-tuning is just a pattern recognition and a pattern repeat machine. That's it. RL, especially with process supervision, directly optimizes the correctness of each step to up to a certain limit. Theoretically, yes. The reward model will penalize an incorrect intermediate inference, forcing the model to revise the step in future outputs. As a result, reinforcement learning tuned model tends to have chains of thought that are more logically sound and tightly linked to the final answer. The word is here tend. They tend to have chains of thought more logically sound. Empirically, process level RL leads to chains where errors are caught early. Sometimes not. A process reward model will learn that if an intermediate result is wrong, the final answer is likely wrong. Thus, the model stops getting rewarded at this point. They are referencing always to the same papers. There are not a lot of independent papers. Interesting. Akin to a human student learning to double-check its step in math problems, RL training models have far few logical jumps. Their solution steps align with the formal reasoning. Some even learn to invoke sub-procedures like factoring, as noted by some authors. On the other hand, the recent analysis warned that fine-tuning can degrade the faithfulness of model reasoning. Beautiful, we have this graph-based and structured reasoning. Now it gets interesting. Okay? SFT can incorporate structured knowledge by training on a representation of that knowledge. Linearized graphs, scientific tables, or code. It is straightforward but needs the model to generalize the structure. RL can complement this by rewarding correct usage of the structured information. Yeah? If a knowledge graph is given, one could have a reward that checks if the model answer is consistent with the graph. The graph PRM work combine both. They fine-tune the model on a corpus of graph problems with chain of thought solution and use then an reinforcement learning fine-tuning step, a DPO, to further polish the reasoning. It's always the same papers. Look, it's always the same papers. So this hybrid produced a model that excelled at graph tasks and improved on other reasoning tasks, illustrating a synergy between supervised fine-tuning and reinforcement learning for the refinement, for the alignment. In knowledge-intensive domains, one worries hallucination, making up facts. Pure supervised fine-tuning on new knowledge can inadvertently encourage hallucination if the model is forced to output facts it did not originally know. Again, this one. Reinforcement learning can mitigate this by incorporating a facility reward or a penalty. Also non-trivial to design, researchers have trained reward models for truthfulness and used the feedback from human resources to make LLMs more factually correct. The result is models that are more likely to admit ignorance and consult provided knowledge rather than fabricate. In short, supervised fine-tuning integrates knowledge into the model, while reinforcement learning can guide how that knowledge is used, ensuring the reasoning step consistent and factual. Okay, yeah, to a certain extent. Yeah, okay, I go with this. Reasoning style and depth. Notable effect on reinforcement learning fine-tuning is that models often adopt a more structured, self-reflective reasoning style. Yeah, because exploring the solution space is incentivized, RL-trained models may try multiple approaches internally. Okay. Yes, we know this. Structured knowledge. Overall, RL seems to encourage a deliberative style. Let me reason step by step carefully because my reward depends on it, while supervised fine-tuning encouraging a descriptive style. Why the reasoning? Because that's what the example did. Okay. Model size consideration. My goodness. So small and medium model, less than 13 billion free trainable parameters. DeepSeek R1. DeepSeek R1. It's always using the same style. DeepSeek R1. DeepSeek R1. DeepSeek R1. DeepSeek R1. Large model, 70B and above. Okay. GPT-4 training details and public, never mind. GPT-4, old stuff. GPT-4, old stuff. GRPO help by cutting the overhead. Data 70 Llama and a 33B. DeepSeek, Yes, PPO setup. Small models require more aggressive training to acquire reasoning, and reinforcement learning can indeed transform a small model's capability, but often via an intermediary of a large model or a careful distillation. In general, this might be true. Yep. In summary, larger models give a higher absolute performance ceiling, and reinforcement learning can squeeze out those last bit of structured reasoning quality. Okay. Hey, advantages, limitation, and emerging trends. Advantages of supervised fine-tuning, we also go with the last one. The limitation is that supervised fine-tuning is bounded by data quality and diversity. Complex scientific reasoning often requires many examples of careful curation, and creating those, especially with a step-by-step annotation structure, can be labor-intensive. Absolutely. Supervised fine-tuning also may not generalize far beyond its training domain. Absolutely correct, whereas an reinforcement learning approach could, in theory, explore a broader behavior than the supervised fine-tuning. Advantages of reinforcement learning. Reinforcement learning also encourages model self-reflection and search. Approaches like tree of thought or self-consistencies, when integrated into training, help the model to learn to deliberate internally. Beautiful, yep. RL opens the door to training LLMs more like agents that can play, try, and refine their approach, a key for complex reasoning. Yes? The flip side is that reinforcement learning is trickier to get right. Its limitation includes sensitivity to the reward design, absolutely. There's a risk of over-optimization where the model might over-specialize to the reward and lose some generality or linguistic richness, hence why a Kullback-Leibler penalty is usually added to keep it from straying too far from a human language. RL is more computationally intensive, beautiful, especially if you go with PPPO. Yes, yeah, ongoing like DPO and Q-learning variants, beautiful. Emerging trends. We are seeing a blending of supervised fine-tuning and reinforcement learning technique to get the best of both. One trend is process supervision, giving step-level feedbacks to guide the reinforcement learning. This has proven highly effective. Another trend is offline reinforcement learning and DPO. DPO from 2023. Yes, GRPO is the removal of the value network, and the use of the group baseline is one example of tailoring reinforcement learning to the practical constraints of LLM training. Beautiful. The same little archives are a use of Bellman equation. Search and reasoning at training time. Yes, test time compute, inference time compute. Yabby. Researchers use technique like tree of thought search, Monte Carlo tree search, or best of n sampling to generate better reasoning traces. Yes, finally! Incorporate Monte Carlo tree search in the reinforcement loop for LLMs. DeepSeek R1 experimented with a Monte Carlo tree search guided training where a value model guided the expansion of the reasoning step, generating new Q&A for the actor. Scaling this up, there was problems. Search base is huge, and the Monte Carlo tree search sometimes gets stuck in the local optima. Field is learning that naive application of search needs refinement, but hybrid approaches, search and learning, are likely the future for complex reasoning. Finally, knowledge integration techniques are advancing. Instead of pre-training a model from scratch, people fine-tune or RL train models to use external knowledge sources. RAG. Come on. Okay. We might see reinforcement learning being used to decide when to trust the knowledge graph versus the model's own reasoning, a kind of meta-reasoning. RL, reinforcement learning, has a problem with trusting its knowledge sources. This is interesting. Multi-modal reasoning using diagrams or formulas. Yes, mathematical deviation. Beautiful. All these trends point towards a common goal, improving LLM reasoning to be more structured, reliable, and aligned with factual or logical ground truths. Supervised fine-tuning and reinforcement learning are complementary tools in this pursuit. Beautiful. In summary, yes, finally we made it to the end, heaven's sake. Supervised fine-tuning provides the essential foundation and knowledge for LLM reasoning, while reinforcement learning techniques fine-tune the model's reasoning process itself, often yielding superior performance on complex scientific tasks. Supervised fine-tuning is simpler and critical for injecting new information, but reinforcement learning with DPO and GRPO is highly effective at honing structured reasoning abilities, especially chain-of-thought consistency, stepwise correctness, and strategic problem-solving. The best results of 2024 Plus often come from combining both, using supervised fine-tuning to teach baseline skills, and then reinforcement learning to refine and align the reasoning. Absolutely! As LLM research progresses, we can expect further innovation in reward design, hybrid search training methodologies, and knowledge integration that continue to push the frontier of AI reasoning in scientific domains. Okay, so we have the DeepSeek Math paper. Then we have here this one, Step by Step 2023. Okay, DPO, supervision, blog from OpenAI, DeepSeek R1, thinking with knowledge graph, DPO, additional references above. It is having a very limited set of research papers, of recent research papers. I would say it misses out on the major part of the most recent AI research paper. So in that respect, also I think it gives a good explanation based on here some focuses here on a very reduced set of AI papers. It gives you a good explanation, but it's missing out simply on the latest technological development here in AI research and in reasoning, unfortunately. And in this respect, the answers provided here by Gemini 2.0, searching the internet, Google has definitely here a lot of advantages. I understand it from the history of Google, but sorry, the answers by Google are simply better, more up to date, include the latest AI research paper. Therefore, I would say, if you look for the latest research, there's a clear win by Google 2.0, the thinking model of Gemini, and the free deep research. Yeah, I have the Plus model and I just have 7 available till March 28. So therefore, I personally now go with Google Gemini 2.0 Thinking Deep Research. I hope you enjoyed this. I hope it provided some insight for you. Please check for your particular task, for your particular domain knowledge, the way you want it to present here an answer. You have your own query, you have your own task. Try it out both models and then you know exactly what you will get. Anyway, I hope you found this informative. Choose the model that you like. And if you subscribe, I see you in my next video.